Good day, sir. I am Early Manuel from RAM 11. And as for our final requirement, we are asked to choose an item in four branch of physics, which is classical mechanics, thermodynamics, electromagnetism, and optics. So this is my book. So in classical mechanics, I chose problem 6.47. So the problem is a force in the positive x direction with magnitude f of x equals 18 Newton minus and multiply to 0.530 Newton per meters. X is applied to a 6 kilograms box that is sitting on the horizontal frictionless surface of a frozen lake. F of x is the only horizontal force on the box. If the box is initially at rest at x equals 0, what is its speed after it has traveled 14 meters? So since the box was at rest at the beginning, when we start to apply the force, its direction of motion will be in the direction of the force and the work will be positive. So putting A equals 18 Newton and B equals 0.53 Newton per meters. From the equation 6.7 sa reference book po natin, which is this equation po, this one, we obtain the work done on the box by the force f of x equals a minus bx from x equals 0 to x equals 14 meters. So plugging in the variables po, the values, we will get this result po, which is 200 joules. So next is let V be the speed of the box at x equals 14 meters. So according to work energy theorem, work is equal to K sub final minus K sub initial in equals 1/2 m times V squared. So plugging in lang din po ang values. So we have here square root of 2 times 200 all over 6. We will get this result. So therefore, the result of speed after it has traveled 14 meters is 18.6 meters per second. So next is thermodynamics. So I chose problem 20.26. So the problem is you make a tea with 0.250 kilograms of 85 degrees Celsius water and let it cool to room temperature 20 degrees Celsius before drinking it. So we are asked to calculate the entropy change of the water while it cools and to calculate the change in entropy for the air while the tea cools, assuming that all the heat lost by the water goes into the air. What is the total entropy change of the air of the system, rather, T plus air? So I also included my explanation here so you won't get lost there while I explain it. So we are given the mass of the T, m is equal to 0.250 kilograms at temperature T equals 85 degrees Celsius, which in kelvins equals 358. Then cooled to temperature T sub 2 equals 20 degrees Celsius, which in kelvins also is 293 K. So step 1, we are asked to calculate the change in entropy for the T. In this problem, there is a change in temperature. So change in entropy is given by this equation. This whole equation po, where C is the specific heat capacity of water and equals 4,190 joule or kelvins. Now we can plug in our values for T sub 2, T sub 1, C, and M, which is 0.250 kilograms, into the equation to get the change in entropy where temperature are in kelvins. So, plug in lang po ang values dito. So, we will get this result. So, therefore, the change in entropy for the T is negative 200 kelvins. So, next is electromagnetism. I chose problem 24.12. So, the problem is the cylindrical capacitor has an inner conductor of radius 1 millimeter and an outer conductor of radius 3.5 millimeters. The two conductors are separated by vacuum and the entire capacitor is 2.8 meters long. So we are asked, what is the capacitance per unit length? The potential of the inner conductor is 300 MV higher than that of the outer conductor. Find the charge on both conductors. So we are given a cylindrical capacitor where the radius of the inner conductor is R sub A equals 2.2 millimeters is equal to 0.0022 meters. And the radius of the outer conductor is R sub B equals 3.5 millimeters, which in meters is 0.0035. Also, we are given the length of the capacitor, which is L is equal to 2.8 meters. So the potential V is between the cylinders is not affected by the presence of the charged outer cylinder, and the capacitance per unit length is given by this equation. So, tulad po ng mga nagawang at formula po, solution, ipa-plug in lang po ang mga values so we can get the final result. So, plug in the values lang po. 2 pi times 8.8854 times 10 raised to negative 12 quantity all over 1n, quantity 3.5 millimeters over 2.2 millimeters. So we will get 120 times 10 raised to negative 12, and this is the final result po. We will get 120 result. So, sa optics po, I chose 33.9 problem, which is light with a frequency of 5.80 times 10 raised to 14 hertz travels in a block of glass that has index of refraction of 1.52. What is the wavelength of the light in vacuum and in the glass? The solution: wave speed for a periodic wave is given by this equation. So we will use this equation later on. The wave advances a distance of one wavelength during one period. So the wave speed is given by this equation then po. So we'll use this also. Whereas v is equal to the speed of wave, t is the period of time, f is the frequency of the wave, and this sign is the wavelength of the wave. This equation is applied to any kind of periodic waves. So to explain further, for a periodic wave, the shape of the string at any instant is a repeating pattern. The wavelength of the wave is the distance from crest to another, or one from through to the next, or from any point to the corresponding point on the next repetition of the wave shape. The wave pattern travels with constant speed and advances a distance of one wavelength in a time interval of one period. So, na-research ko po itong theorem na ito. So, pwede po siyang i-apply sa problem po na ito. So, step 2, the frequency is the same in any medium as the source is also same. So, plugging in the values, we will get this po. So, values 3 times 10 raised to 8 meters per second all over 5.8 times 10 raised to 14 hertz is equal to 517.24 nanometer. So that's all po. Thank you.